Welcome to the Deep Dive. Today, we're plunging into a challenge that's really central to the future of AI.
Mm-hmm.
How do we make these incredibly powerful, but let's face it, inherently unpredictable?
Yeah.
Large language models truly reliable for the real world?
It's a huge question.
Yeah. Like many of you, I've seen the magic and maybe the occasional weirdness from LLMs.
Oh, definitely. The oddities are part of the package right now.
So we've poured through a stack of insightful sources,
Mm-hmm.
including a recent piece from Stack Overflow, to really unearth the crucial strategies for building trust into these dream machines.
Right.
Consider this your shortcut to understanding GenAI determinism.
And it's such a critical topic, especially as generative AI moves, from being this fascinating novelty into a really foundational layer for essential enterprise tools.
Absolutely.
We're going to unpack what it really means for a system to be unreliable by design, why that's just, a non-starter in business environments.
Yeah, you can't have that.
And the practical, actionable steps people are actually taking to mitigate those challenges. Our goal here is to show how these powerful tools can be harnessed predictably, safely,
Right.
tackling everything from, basic factual errors right up to complex, maybe even runaway AI agents.
Okay, so let's get to the core paradox then.
Mm-hmm.
LLMs, fundamentally non-deterministic.
Mm-hmm.
You ask the same question 10 times, you might get 10 different answers. All delivered confidently, I should add.
Exactly. Equally plausible, often.
It's wild. But here's the kicker. This isn't always seen as a bug. Sometimes it's framed as a feature. Can you explain why it's designed that way, and then why that feature becomes such a headache in enterprise settings?
Well, what's fascinating is exactly that duality you mentioned. They're often called dream machines for a reason. They're designed to invent, to be surprising, to generate novelty.
Yep.
And that creativity, it sort of requires a degree of unpredictability, almost by definition. Like Dan Lyons from Linear B puts it, any probabilistic model is just sometimes going to be wrong.
Right, it's baked in.
It's inherent. But then you flip the coin. For enterprise software, that's a big no-no, as he says. Businesses absolutely need reliable, auditable, repeatable results.
Can't function without it.
No. And Daniel Loretto, the Jetify CEO, notes that unpredictability makes predicting the behavior very hard. And that's not just, an inconvenience.
Go.
For businesses, it hits their ability to ensure compliance, forecast performance, build trust and automation. It's the difference between having a helpful assistant and, frankly, a potential liability.
Okay, so break that down. What does this mean for you, listener, especially if you're thinking about integrating GenAI into really critical systems?
Yeah.
We're not just talking minor quirks here. We're talking like preventing a banking system from double charging credit cards.
Exactly. Or giving conflicting medical advice, perhaps.
Right. The stakes get much, much higher.
Yeah.
Tariq Shakat, Sonar CEO, highlighted how in banking code, for instance, hallucinations are just a much bigger deal than if they pop up in, say, a kid's web app.
Precisely. And even with really advanced techniques like RAG, retrieval augmented generation,
Yeah, which tries to keep it factual.
it tries to ground the responses in factual info, pulling from trusted sources. But even then, hallucinations can still happen.
Okay.
Amara Awadallah from Vectara mentioned that even top models like Gemini 2.0 still have hallucination rates around maybe 0.8%, 0.9%.
Which sounds low, but
It sounds incredibly impressive, and it is. But he also noted there are many, many fields where that 0.5% is not acceptable.
right. Finance, healthcare.
You name it. So it raises this really important question. If we can't completely eliminate the errors, how do we contain them effectively? How do we manage that risk?
It feels a bit like, inviting the entire internet, unfiltered, to a dinner party. You just know some wild stuff is going to get said.
That's a great analogy, actually.
So if LLMs can output this wild stuff because their training data includes, everything, how do you stop them misbehaving when they're actually deployed in a product? I guess this is where sanitizing inputs and outputs comes in.
Yes, absolutely. Trust in enterprise apps hinges on accuracy and safety. And the solution really involves putting in place what we call guardrails.
Guardrails, okay.
Think of them as rules and filters, and they apply on both sides. The prompts you send to the LLM and the responses you get back.
How did that work?
Well, Miriam Ashuri from IBM's WatsonX.ai explains it well. On the input side, guardrails protect the model from jailbreaking.
People trying to trick it.
Exactly, trying to trick the AI into bypassing its safety protocols. And then on the output side, the guardrails filter out harmful stuff, hate speech, abuse, profanity, or, crucially, personally identifiable information, PII.
Like social security numbers, credit cards.
Things you absolutely don't want the AI spitting out.
That seems pretty straightforward for obviously bad stuff.
Right.
But what about those unexpected cases where an LLM is maybe just trying to be helpful but goes completely off the rails?
Yeah.
I remember reading an example, I think Keith Babo from Solo.io mentioned it, where an LLM revealed a social security number when someone just asked for fun facts.
Yeah.
How do you guard against that?
That's a perfect illustration of why output filtering is so critical, even when the input itself isn't malicious.
Right, the prompt was innocent.
Grump was innocuous, yeah.
Hmm.
But the data the LLM accessed and then generated could still be harmful or expose sensitive information. And it gets even more complex when you think about AI agents.
Agents that can take actions.
Exactly. Agents that can use tools, interact with other systems, take real actions in the world. Christoph Kohnreitz at Salesforce really emphasizes that guardrails are essential there to define the parameters of what an agent can do.
So setting boundaries.
Setting clear boundaries, yeah. Preventing them from getting out of control and maybe, booking 1,000 flights by mistake or something.
Okay, so the core principle here seems to be knowing where to draw the line. Like, don't force the LLM to do tasks that are inherently predictable and better handled elsewhere.
You've nailed it. Joe George, the CEO of Orcs, makes this point really clearly. For those extremely deterministic pieces of a workflow,
Like sending an email.
exactly, sending
Right.
an email, firing off a notification. If there's a standard, reliable API for it, use that API. Don't ask the LLM to do it.
Makes sense.
It's all about leveraging the LLM for its unique strengths.
Mhm.
The reasoning, the language generation, maybe the creativity, and then offloading the predictable, repeatable actions to reliable, traditional tools. That distinction is absolutely key for building robust, trustworthy systems.
Okay, let's shift gears a bit. We're used to traditional software observability, right?
Yeah.
You've got your logs, metrics, stack traces.
Standard toolkit.
Yeah. But with LLMs, it feels different, more opaque. Abby Kearns, the Olympic CTO, called it obtuse and said it feels like we're reinventing a lot of that tooling in real time.
Yeah.
How do we actually get visibility into these black boxes?
It's a huge challenge, honestly, because those standard software metrics, they don't really map directly to LLM performance, especially not in real time. Sure, you can get aggregate metrics after the fact, hallucination rates over a month, bias scores, toxicity levels. You can find leaderboards on Hugging Face comparing models.
But that doesn't help when something breaks now.
Exactly. It doesn't help you debug a live production issue. What's really needed, according to Daniel Laredo again, is a system of record.
A system of record.
Yeah, something that logs every single step meticulously. The user's original input, the prompt that actually went into the LLM internally, the LLM's raw response, any tools that might have called along the way,
The whole chain.
the entire chain of events. This comprehensive logging is what allows for auditing, for debugging, for actually understanding why the LLM gave a specific answer.
And this next idea is really fascinating, maybe a bit meta. Some people are actually using LLMs to observe other LLMs, this LLM as judge approach.
Yeah.
It sounds a bit like letting the student grade their own homework, doesn't it?
It can feel that way at first glance. But the thinking is, if you use multiple different models, especially diverse ones, to evaluate an output, you can actually get surprisingly reliable assessments.
Interesting.
Mark Doble, the CEO of Alexi, he used a great analogy. He said, locking one smart human in a room with a pile of books won't necessarily make them super intelligent,
Right.
but put 5 people in a room, they're debating, discussing ideas, correcting each other. That collective intelligence, that debate, leads to a higher level of understanding.
So multiple AIs checking each other's work.
Kind of, yeah.
Yeah.
Applying that same principle to interacting AI agents or evaluators.
And what about this chain of thought method? That sounds like another way to peek inside the box. How does that help with observability?
That's another really vital technique. Mariam Ashuri referred to it as chain of reasoning. Essentially, you break down a complex prompt into smaller sequential steps. And then you evaluate each of those intermediate steps, often using other LLMs as judges, like we just discussed. It fundamentally improves the granularity of your LLM logging. You see the process, not just the final result.
But it's not perfect, right? There are still unknowns.
Oh, absolutely. Raj Patel, who leads AI transformation at Holistic AI, raises a really important point here. He says, interpretability of outcomes has a big question mark over it.
Meaning we don't fully get why it does what it does.
Exactly. Things like how tokenization affects meaning. the precise mechanics of attention mechanisms deep inside the model.
Hmm.
These are still not fully understood, even by the experts building them. So while we're making definite strides in observability, a lot of the focus still has to be on rigorous output testing to ensure reliability day to day.
Okay, so we've covered what goes in, what comes out, and how to watch it. But what about the bigger picture? LLMs often don't work in isolation, right? They're part of a larger workflow, calling other services APIs.
Mm.
And those other services can be unreliable too. What happens then? Imagine a long process. Maybe an LLM calls an API. That API fails.
Mm.
The whole thing could fall apart.
You've hit on another critical point. These GenAI workflows, they do frequently interact with external APIs and services. And if an LLM call, or maybe an external API call, it depends on, fails midway through some multi-step process, well, it can be incredibly costly.
How so?
Jeremy Edberg, the CEO of DBOS, he points out that AI is inherently unreliable, and failures mean you might have to rerun expensive prompts.
And you might get a different answer the second time.
Exactly, because it's non-deterministic. So you get a different, possibly equally unhelpful response. And Qian Li, a co-founder at DBOS, adds that the LLM APIs themselves can be unstable. They can fail, they have rate limits.
Right, you hit the limit and it stops working.
Yeah, so each failed call isn't just frustrating, it's genuinely expensive in terms of compute resources, API costs, and lost time.
This definitely raises a crucial question then. How do you make sure these complex multi-step workflows actually run reliably? How do you guarantee they complete as intended, even if some parts are flaky or unpredictable?
The key emerging solution here is something called durable execution technologies.
Durable execution.
Yeah. Think of it like autosave in a video game. Or maybe a better analogy is like a really robust transaction log for a complex financial operation.
Okay, I think I follow.
As Kinali explains, it's basically about checkpointing your application. So when your GenAI app or agent processes a prompt or infers some data or calls an external tool, these durable execution systems store the state and the result of each completed step in a persistent database.
So it remembers what it's already done successfully.
Precisely. So
Okay.
if the system crashes or an API call times out or whatever failure occurs, the workflow can restart and pick up exactly where it left off. It won't repeat the steps that already succeeded.
So it prevents rerunning those expensive prompts unnecessarily.
Exactly. Maxim Fateev, who co-founded Temporal, confirms this. He says if a call's result is recorded, it will never repeat that call. It doesn't matter if it's AI or whatever. It ensures what we call exactly once execution for each step.
Got it. So it's another powerful strategy, really, to ensure that the predictable, sort of linear parts of a workflow are handled with absolute reliability, even when they're interacting with the less predictable bits, like the LLM itself.
That's exactly right. And Ju George from Orcs, his point comes back here too. Remember, when building agents, there are always those pieces that are extremely deterministic.
The email sending, the notifications.
Right. If you have a solid API for it, use it. Don't make the LLM guess. This whole approach, it empowers developers to be smart about orchestration. They can pick and choose precisely where the LLM's unique capabilities add the most value.
The reasoning, the language understanding.
Yeah. And then use traditional deterministic methods wherever reliability, efficiency, and maybe cost-effectiveness are paramount. It's about using the right tool for the right job within the workflow.
We have covered a lot of ground today. This deep dive, it's really shown us that while large language models are designed to be these incredible, dream machines that invent and surprise us,
They're amazing.
their inherent non-determinism presents some really significant, fundamental challenges for building enterprise-ready software.
Definitely. And ultimately, making GenAI reliable isn't about one silver bullet. It involves this multi-pronged approach we've discussed, rigorously sanitizing inputs and outputs with those guardrails to control behavior, implementing these new kinds of observability systems to track their unique behaviors, peek inside the box a bit, and leveraging these durable execution technologies to make sure complex workflows actually complete predictably, even if individual bits fail along the way.
It really feels like it's about adapting, maybe evolving standard software engineering practices for this new, incredibly powerful, but inherently risky technology.
Well put.
Raj Patel from Holistic AI, his quote sticks with me, "Trust is key."
Absolutely fundamental.
Takes years to build, seconds to break, and quite a bit to recover. So for you, the listener, understanding these strategies we've talked about is just crucial. Whether you're developing the stuff, deploying it, or even just using GenAI in your work or daily life.
And maybe this leaves us with a final important question to ponder. As LLMs become more and more deeply integrated into our lives, into critical systems, how much of this unpredictability are we as a society truly willing to accept for the sake of that innovation? And where, absolutely, must predictability reign supreme?